This is the beginning of Chapter 12 homework for Physics 102A at Porterville College, starting with number 25. These first few problems are just straight conversions between Fahrenheit, Celsius, and Kelvin. So question number 25 says it's 5 degrees Fahrenheit. What is the temperature in Celsius? So for that we use the conversion that Celsius is 5/9 Fahrenheit minus 32. So just plug in for Fahrenheit 5, and that gives negative 15 degrees Celsius. Number 27 says calculate the Fahrenheit and Kelvin equivalents of A, nitrogen's boiling point, negative 196 degrees Celsius. Going from Celsius to Kelvin, you simply take the Celsius and add 273, so that'll give 77 Kelvin. For Fahrenheit, then once you have Celsius, again multiply by 9/5, add 32, and you get negative 320.8 degrees Fahrenheit. Part B is converting 327 degrees Celsius to Kelvin, so you add 273 and get 600 Kelvin. Then convert the Celsius to Fahrenheit, multiply by 9/5, add 32, and it rounds to 621 degrees Fahrenheit. Number 32 refers to absolute zero, the lowest possible temperature. So if you have Kelvin, you subtract 273 from it to get Celsius. So here we have 0 minus 273, and it's negative 273 degrees Celsius. Once you have the Celsius, converting it to Fahrenheit is a matter of multiplying by 9/5 and adding 32. So 9/5 of negative 273 plus 32 is negative 459 degrees Fahrenheit. For number 35, the question is, what temperature is both the same in Fahrenheit and Celsius? And the first thing, what would be good to do, if you have a thermometer handy, or maybe you can look on the internet for an image of a thermometer, look at both the scales and see where do they both say the same thing. And if you do that, you'll see it's about negative 40 degrees Celsius. But now let's do some math. We know the conversion that Fahrenheit is 9/5 Celsius plus 32. So if they're going to be the same thing, let's let x equal the temperature, both Fahrenheit or Celsius. So we'll let the Fahrenheit be x in this equation, and we'll let the Celsius be x. They're the same value. So this equation, the conversion equation, by the way, you can also use the Fahrenheit to Celsius conversion equation. It doesn't matter. But when you let both temperature values equal x, you have x equals 9/5 x plus 32. A little bit of algebra. Subtract 9/5 x from both sides, and you have negative 4/5 x equals 32. Then x equals negative 5/4 times 32, and you get negative 40 degrees. Number 37 involves length expansion or contraction. So we take note of the fact that the original length, I'll call that L0, is 50 meters. Temperature is 20 degrees Celsius. We need to know the coefficient of length expansion for steel, and that's 1.2 times 10 to the negative 5th per degree Celsius. Question A is asking about when the temperature is 32 degrees Celsius. And the question is asking what is the new length. So the new length is the old length plus delta L, where delta L is L0 times alpha times delta T. So 50 meters is the original length plus 50 meters times 1.2 times 10 to the negative 5th times, and be careful here, delta T, the change in temperature is 32 minus 20. Change is always final minus initial. So 32 degrees minus 20 degrees Celsius. When you do that, you get 50 meters, the original length, plus the change, which is 0.0072 meters. So the final length is 50.0072 meters. which means it's increased by 7 millimeters in size. And just consider for a minute what the comparison between how long it was and how much it changed. It was roughly, the steel beam was roughly half the size of a football field, half the length of a football field. I'm sorry, it's a steel measuring tape. Half the length of a football field, and with the temperature change, it's increased by almost a centimeter. Part B refers to a temperature of negative 10 degrees Celsius. So we have the original length, 50, plus, and here's the delta L. It's 50 times 1.2 times 10 to the negative 5 times, and again, be careful with final temperature minus initial. Negative 10 degrees minus 20 degrees. This should give you a delta T of negative 30 degrees. The effect of that being negative means that this whole delta L term will be negative, which means when we cool it off, it decreases in length. So 50 meters plus the change, which is negative 0.018 meters, 49.982 meters is the length of the measuring tape at a temperature of negative 10 degrees Celsius. Problem number 39 is an interesting case biologically where the length of the bone has different coefficient of expansion than the width. So the long length has a coefficient of expansion, and I'll call that alpha L, of 8.9 times 10 to the negative 5 per degree Celsius. The short length, I'll call that alpha sub S for short, is only 5.4 times 10 to the negative 5. So this bone is going to increase along its length and its diameter at different rates. Now we need to do something. We're going to need delta T, and since alpha is given in terms of degrees Celsius, we're going to need our change in temperature in degrees Celsius. So we have a final temperature. The problem refers to this person having a fever of 104.5. We need the original temperature. Now it's not saying in the book what the person's original temperature is, but we'll go with average body temperature. Most people think and are taught in school that it's 98.6 degrees Fahrenheit. That actually comes historically from an error in rounding off and unit conversions. The average body temperature for humans is actually 98.2 degrees. When you convert those to Celsius, you get 40.277 and 36.8 degrees Celsius. So do that subtraction and you get a change in temperature of positive 3.477 Celsius degrees. Now we apply that to our length expansion. Here I'm treating separately. At the top of the screen you see how I deal with the length of the bone, and at the bottom how we deal with the diameter of the bone. So along the length of the bone, delta L is its original length, 43.2 centimeters, times 8.9 times 10 to the negative 5 times the change in temperature, 3.477 degrees Celsius. Now, I'm okay keeping this in centimeters. The last two terms, the units are going to divide out, and so my answer is going to be given in centimeters. What I'm left with is change in L, change in length, of 0.01337 centimeters along the length of the bone. Across the diameter of the bone, change in length is the diameter, 2.75 centimeters, times alpha, 5.4 times 10 to the negative 5 per degree Celsius, times 3.477 Celsius degrees. And what I get is that the diameter, its change in length, is, boy, I can't even read that, 5.163 times 10 to the negative 4. Now, since I can't read my own handwriting, now's a good time to do some quick, sorry to do this on film with you guys. This is 3 times 5, that's going to be about 15, times 3, that's going to be about 45, 50, yeah, okay. So this must be the start of a parenthesis that I never finished, and we'll go with the change in length is 5.163 times 10 to the negative 4.